Here we go with 3-3. This section here is all about slope. And if you remember from Algebra 1, the slope is the steepness of the line. And you can describe slope by saying the rise compared to the run, or the rise over run. The formula for slope, we use the variable m to calculate, and we say that m equals y2 minus y1 over x2 minus x1. Another way of saying this is you can say that this is the difference of the y values divided by the difference of the x values. And you may have just coordinates that they're asked to find the slope of, or you may have them on graph paper. I will show this to you first on graph paper, and then we'll do a couple where you just have a coordinate written out. So here it asks us to calculate the slope of each line. You could write out what these coordinates are, or what you could do is you could just kind of look at their placement and then count it on the graph paper. Either way would be correct. So remember, slope is the rise compared to the run. And I always look from like the point on the left to the point on the right as I'm looking at this. So from this point going straight down, it's actually not rising, it's falling. It's falling 1, 2, 3, 4, 5, 6, 7, 8. So this slope would be -8. And then it's going over to the right too. So -8 over 2. And you would just want to simplify this anytime that you can. So I would say the slope of this line is -4. Or you can think about that going down 4 and over 1. Down 4 and over 1. The overall steepness or that slant of that line. For this one here, it's rising 1, 2, 3, 4, 5, 6, 7, but it's not going over at all. So that slope would be 7 over 0. But if you remember, you can't divide anything by 0. It's undefined. So what I'd want to see you write for if the slope is of a vertical line like that, the slope is undefined, or you could choose to write no slope. Please don't leave it like this is like 7 over 0. Write undefined, or if you'd rather, no slope. For this one here, we have G to F. And notice that those are kind of right on the corners of the boxes. I can't say this is up 1 over 1 because that's not exactly at that point. I need to be a little more specific with this. Noticing here, this is going up 1, 2, 3, 4, 5, 6, 7. So this slope would be 7 over, and then 1, 2, 3, 4, 5, 6, 7, 8. So it's almost going up 1 over 1, but it's just a little bit off like that. I can't simplify 7/8, so I'll just leave it. And then this last one, if you notice here, it's not going up at all. So that would be like 0 over, let's see, 2, 4, 6, I think I'm counting 8. This right here would be just a slope of 0. It wouldn't really matter how much it's going over because that's just a flat horizontal line. So 0 divided by any number is 0. Remember, any number divided by 0 is undefined because you can't be dividing things by 0. So these are just if they have graphs like this for you. If you would like to do an example of this where we just have coordinates, if it's on graph paper, you can count it, but not all coordinates would be things that would work out nicely to graph. So if I'm looking at this, let's see, this was -3, 1, 2, 3, 4, 5, 6, 7. So the coordinate -3, 7. And this other coordinate is -1, -1. I'll show you how we can use the slope formula to plug these numbers in, just in case they're not drawn out on the graph or if they're bigger and you don't want to graph them. So remember that you're going to find the difference in the y values. And the formula says to take the second one minus the first one. So I'll do that here. So -1 minus 7 and then the difference of the x values, so -1 minus -3. Here I'm going to have to add the opposite, so this is going to be -8 over 2, which if you remember is -4 for our final answer after we divide those. Or maybe you have something like 23, 4, and -5, 7. This might be one that if that's what the directions asked you to do, you wouldn't probably want to graph 23, 4, at least not to scale. It wouldn't work out as nice. So you could simply use the formula for slope where you subtract those y values. So y2 minus y1 is going to be 7 minus 4. And then x2 minus x1 will be -5 minus 23. So in this case, this is going to be 3 over -28. And then if and when you can simplify this, you would need to. For this one here, you could just leave it like that. So I included this chart on here for you just to kind of remind you, positive slope, it goes, I think of it going like uphill. As you go from left to right, a positive slope line will be going up. Doesn't have to necessarily be very steep. You know, any of those would be positive slope. Negative slope is going down from left to right. Zero slope is a horizontal line. And undefined slope, or if you would like to write no slope, I've had students tell me that that's what they've learned before in the past. Those are the same thing. I prefer the word undefined would be a horizontal, or sorry. I prefer the word undefined. That would be your vertical line. So another example of this would be written out like this. If you remember slope, another way of kind of defining slope is it's the rate of change. And we use rate of change more frequently when we have maybe a story problem, and it's not just like the coordinates are written out for you. So I'll read through this. It says, in the year 2000, the annual sales for one manufacturer of camping equipment was $48.9 million. So if you would like to think of that as a coordinate, you have the year 2000 and you have 48.9 million. That's one coordinate. And in the year 2005, it says that it was 85.9 million. So I can think of this as a rate of change, how many millions of dollars it's going up each year. And I can use the slope formula to calculate that. So I have 85.9 minus 48.9, and then 2005 minus 2000. So what I'm looking at here, and if you need to like go ahead and grab a calculator, I thought I could pull this up to kind of show you guys better. Let's see, let me move it. There we go. So what I have here is I have 85.9 minus 48.9 to get 37, and then that's over 5 years. So then what I could do is I could divide that by 5. So what this is saying is this is $7.4 million of increase every year. So I'm going to write that out. 7.4 million per year. And the question's asking me if the sales rate is a consistent rate, the same rate, what will the sales be in 2015? So what I'm going to do is I'm going to take what it started out with in the year 2000, so the 48.5, excuse me, and then I'm going to add 15 years worth of the 7.4 million each year. I'm going to come back over here to the calculator. I'll multiply that by 15. So this is how much additional it will be for those 15 years. But then I also have to add that to what that initial rate was in the year 2000, the 48.9. So the total sales that could be expected in the year 2015, would be $159.9 million. And don't forget to include the units on there, especially the million, because it's a huge difference between just 159.9 if you were to just write that out. A couple other things to review if you just want to kind of put some marks on here. Slopes of parallel lines, like these two slopes here. If you notice, this one has a slope of 4, this one has a slope of 4. Parallel lines will always have the same slope. And lines that are perpendicular, this one being -1/4, it says here that the product of their slopes is -1. What I prefer to write for this is that their slopes are opposite reciprocals. And I think that's easier to remember than that their product is -1. It's saying the same thing, just using some different words. So let's say I have a slope of one line that has a slope of 2/3. Well, its opposite reciprocal, opposite would make it negative because it was positive. And then the reciprocal, remember, is when you take that fraction and you flip it upside down. So the opposite reciprocal would be -3/2. Or for this example here, 4, if you were to think of that as a fraction, would be 4/1. So the opposite reciprocal would make it negative, and then you'd flip that over to be -1/4. So however you want to remember it is fine. I remember opposite reciprocals, or they have to multiply together to be -1. Either way, you'll get the same answer. Okay, so these last couple of examples we have here, we want to tell if these lines are parallel, perpendicular, or neither. And what we're going to do is we're going to look at their slopes, and then we're going to graph it to just kind of double check. So the slope of line AB, I'm going to subtract those y values, subtract those x values. So the difference of the y values will be 0 minus 13. And then the x values, -11 minus 14. So I have -13 over -25, which when I just kind of clean that up a little bit, I'm going to just write 13 over 25. For the slope of CD, I'm going to have here, let's see, -5 minus 7 and -4 minus -3. Remember, you add the opposite when you're subtracting negatives. So this one here is going to be -12 over -1. So looking at these are not the same number. These are not, well, sorry, this would be +12. And they're not opposite reciprocals either. So I know the answer to this one is going to be neither. What I can do over here is I can just do a little double check. So because of the scale here and because these numbers are a little bigger, I'd scale them each by 2s. So I have 2, 4, 6, 8, 10, 12, 14, and then 13 would be there. -11 would be 2, 4, 6, 8, 10, -11, 0 would be right there. So looking at this, let me see if I can pull up my line tool. Whoops. And connect those 2 points. So there's my line AB. For that next one, I have -3, 7, 2, 4, 6, be right there. And -4, so, and then -5. So 2, 4, 5. don't know why that thing keeps flying over there. Let's see. Do that again. Be right there. Weird. Anyway, if I connect that line, well, let's do it like this. Hopefully you can see that those are not parallel. They're definitely not parallel. They're not perpendicular either because that would have to be a perfect 90-degree angle, and it's not. So this would be neither. Okay, and then for this last example, they just want us to draw on the graph here. They want us to draw a line that contains this point and is perpendicular to line QR. What I would do first is I would find the slope of line QR so I can tell what the slope of the line that's perpendicular to it is going to be. So when I find the slope of this line, I have -6 minus -2. Make sure you add the opposite. And then 0 minus -6, again having to add the opposite here. So I have -4/6, and then when I simplify, that's going to be -2/3. So the slope of the new line that's perpendicular to this line is going to be its opposite reciprocal. So because this is negative, the new slope will be positive, and it'll be +3/2. So in other words, I'm drawing a line that contains this point and has the slope. So I'm going to start by going to the point 0, 1, which would be right here. And then if it's going to have this slope, it's going to be going up 3 and over 2. And you could do that a couple times, up 3 and over 2, or down 3 and backwards 2, to get that line drawn in. What I would even do then is probably just graph this line, QR, just to make sure that my answer makes sense. So -6, 1, 2, 3, 4, 5, 6, -2, and then 0, -6. I guess I didn't make this first line go quite long enough. Just kind of extend that down. So then what you can do is you can see that this other line is going to be perpendicular to it, and the red line is my answer there.